So I just want to say hello. I'll share my webcam quickly just to say hello before. Hey, hope everything is fine there. Thanks for joining. I just flew back from India, so it's really cool to jump right away with talk about AI online like this. It's my first webinar as well, first time live on the webinar, so I'm going to be a newbie, and hopefully there's not so many mistakes done. Luckily, I have a good team of organizers behind that. I got to make sure things run smoothly. So, but yeah, I'll shut down the webcam now, and let's get started. All right, so we're talking about AI and deep learning at Amazon today. So, in particular today, we're going to explore some of the cloud native, especially AWS Cloud native machine learning and deep learning technology that address the different use cases. And from Lex, with using natural language understanding or Poly, that is doing text-to-speech recognition and things like machine learning or the deep learning AMI. So we're going to look a little bit at everything. So myself, I'm Adrian Hornsby. I'm technical evangelist with AWS. My job is pretty much traveling the world and talk about technology. So that's what we're going to do today. And AI is very nice. So, but before we go into those services, I want to talk about what is AI a little bit, especially how do we talk about AI at Amazon, talk about our ecosystem. We're going to talk a little bit about how customers are using AWS and do some wrap up. I'm going to do a lot of demos during that talk, so hopefully the demo gods are going to be good with us today. So what is artificial intelligence? So we refer to artificial intelligence as a system or service which can perform tasks that usually requires human intelligence. So that really pretty much encounter things like deep learning, machine learning, right? So when we think about artificial intelligence, and especially when we talk about machine learning or deep learning, we talk really about those in the grand vision of artificial intelligence. And artificial intelligence is not something new. In fact, it's something that's been taught pretty much for about 60 years. And the first person really that talked about AI was Frank Rosenblatt in 1957 with he was demonstrating an electromechanical neural network called the perceptron back then. And basically, it was a 20 by 20 pixel system able to recognize images, and the pixels were light bulbs. Right? And it didn't stop there. In 1975, there's a person called Paul Verboers that published a very important article called the backpropagation. And basically, it was a very important algorithm still used today that allows better and faster training of neural network. And basically, without that backpropagation, it would be very, very difficult to run and calculate neural networks today. So, if we discussed about those neural networks for so long, what's wrong with them? Why do we see the rise of neural networks really today? Because if you look at basically the trends of AI, you can see that actually the trending started pretty much in 2011 and not in 1957, right? So basically people have talked about AI, but it never became really mainstream. So what was the problem? But before we try to understand the problem, we need to understand how an artificial neural network works. And basically, you can see here a neural network as an input and an output. And between the input and the output, there's something called a hidden layer. And basically, it's a layer of neurons. And a neuron is very a simple construct. It sums multiple weighted input to produce an output, right? And they're organized in layers. So a neural network can have 1 to thousands of different layers, right? And the beauty of those neural networks is that actually they are self-organizing. So giving a large enough data set as input, the neural network will be able to learn automatically how to produce the correct answer, right? But there is something really interesting with those is the training phase and the self-learning feature are very well adapted to solve informal problems. But there's a big catch. They involve a lot of mathematical operations. And those math operations, they tend to grow exponentially as the data size increases, especially as the number of layers increases. And that is called the curse of dimensionality, right? So there is never enough computing power available to run them at scale, and there was not enough data available back then. So a neural network, in fact, need a lot of data to learn properly, right? The more data, the better. And until recently, there was simply not enough of this data to be able to train those neural networks. But by the late 2000s, there was 4 things that made large-scale neural network possible. The first thing is algorithm, right? So in 1998, there's something called convolutional neural networks that was basically published. And it's a new type of multi-layered network. That's what we call now deep learning networks. And those networks dramatically reduce the cost of network training because they reduce computing. The second thing that happened is we started to have very large amount of available data sets, whether you call text, pictures, movie, music, everything digital. And those could be used to train neural networks. And before, like 15 or 20 years ago, there was simply not enough digital data available for researchers to train those neural networks. Similarly, GPUs came basically in the picture, and those are extremely good for training large-scale neural networks. Especially, they are able to do the processing in parallel, which increases the capabilities. The fourth is really the cloud computing, and because it brought elasticity and scalability, and especially for developers and researchers, because it allowed them to use as much infrastructure as they needed for training the network. Especially if they didn't have to buy or build the infrastructures that is needed for training those neural networks, right? So this is a big difference from 20 years ago, where if you wanted to train the neural networks, researchers and scientists would have had to pay and to invest in very large-scale infrastructure. But with the cloud, you can really just buy on demand, do your experiments, train your neural network, and then just shut it down. So we switched from $1 million of investment into basically a couple of $100 to be able to train neural networks. And AWS basically sits pretty right there in the middle, since we allow people to use all this computing power and use algorithms to train the data. And we also offer, of course, GPUs and acceleration for those neural networks. So what's the core promise and why people are so much interested in AI? And I would say the primary thing is innovation. Basically, whether you're creating new features or a new product, basically AI and deep learning gives companies and businesses new ways of exploring the data they have. So it's also not a capability to providing new experience or product categories. Or also breakthrough researches. In fact, there's a lot of advance in science that has been made simply because of deep learning. And we're going to see a couple of examples coming later. So how do we use AI at Amazon? Because, well, you probably heard that actually we are running our fulfillment centers with thousands of robots, right? And actually those robots are filled with AI to be able to optimize the delivery of packages to our customers. We also have, of course, a very famous Alexa, which is fueled by natural language understanding and automated speech recognition. And my Alexa just started in the background. We also have an initiative for doing drones. probably heard about Prime Air, and this is using computer vision technology to deliver packages for the last miles, and packed with, of course, machine learning and deep learning. And also Amazon Go, which is a very interesting concept that anyone can enter a shop and basically take what he needs or what she needs and just leave the shop. And the whole experience is monitored by computer vision. And a lot of AI that is basically improving the retail experience for our customers. And of course, we also have thousands of engineers at Amazon or AWS committed to using machine learning for improving customer experience, whether it's from the fulfillment and logistics to AWS, where we use machine learning daily to, for example, optimize the type of instance we have in regions, right? So from this AI madness at Amazon, we've in fact developed a bunch of services and framework and platform that we want to put in the hands of every developer, right? Whether you're talking about very high-level services like Amazon Recognition or Amazon Poly to, in fact, do-it-yourself deep learning, like using, for example, the AWS Deep Learning AMI. And we're going to look a little bit at those. But we have a very rich ecosystem of services that you could use to fulfill your requirements. And in AI today at AWS is very, very popular. In fact, is the most popular topic if I talk about my talks. And there are a lot of customers interested by using AI, and there are a lot of customers currently using AI very successfully, whether you talk about Capital One, Pinterest, or FINRA, that are using daily AI, right? So really, there's a lot of customers using AI. Let's look at the upper level, so the AI services. And especially, let's start with Amazon Recognition, Amazon Poly, which is our text-to-speech engine. So Poly is very interesting. It's a very simple service. You give it a string or text, a string of text, and then it will return basically an MP3 or an audio stream that will be a lifelike speech of the string you've given as an input. So it should be something like this. I hope you're going to hear what it says.
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
Right. So it's able to take an input like today in Seattle, WA, it's 11 Fahrenheit, and make something actually more human, because no one would really say WA or 11F, but in fact they would say Washington and Fahrenheit, right? So actually Poly uses deep learning under the hood to extract context from the string and return a meaningful audio file.
We live for the music live from the Madison Square Garden.
And similarly, you heard here that it's able to separate between live and live, depending on the context of that. Poly does support as well what we call the speech synthesized markup language, SSML, so that you can tune the speech. For example, in that case, I want the spelling of my name to be letter by letter. So I can use the markup language to tell Poly to interpret a set of characters as letters.
The spelling of my name is Adrian.
Right. I want to show you actually a couple of use cases, or especially one use case that is very interesting, and then we'll do the demos. The Washington Post actually started using Poly to turn their web page, and especially their news web page, into a podcast. So basically, people can now have Poly talk so that people can save time or they can read the Washington Post while on the move. Another use case, which was just released today, which is very interesting, is YCAM case study, and that's in the UK. Basically, they're using Poly here to provide a human-sounding voice. And what they do is they monitor, they are in the security market, and they are able to use Poly to tell what's the situation with the monitoring. So, very interesting use case. But let's go back to the presentation and look at the API. The API is very simple, so if you're a developer and you want to integrate Poly inside your application, you can use whether the SDK or the CLI. This is with the CLI, and you would just call AWS Poly synthesize speech, and then pass the speech as a parameter here, and then define your output, and then the voice that you want to use. There is currently 24 voices in 47 voices in 24 languages. So there's a lot of choice. But let's have a look a little bit at the console so that you can see by yourself. So this is Poly console if you go into the AWS console, and then you can see like this. I'm using plain text here, and I can have it start.
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
Right, and then here I can also test my markup language.
The spelling of my name is Hornsby.
And you can select voices. So on the API, the voice ID is actually the name of the voice. So basically, I can use different voices.
The spelling of my name is Hornsby.
And then what you can do, you can very easily integrate Poly. And this slide you probably don't have because I just added it, but I just wanted to give you an example of how the Washington Post is doing. Is basically they use AWS Lambda to retrieve the text from an RSS feed or the web page, and then send that to Poly. And then if you're interested in adding the code, you can access the code here on GitHub on Polycast. And basically what it does is it gives you access to a Lambda function here, which you can call with some parameters. For example, here I give an RSS feed, and this is the AWS blog on AI, and then you can run it, and then basically that will store lots of MP3 file inside your S3 bucket of your choice, and then you can use that to launch to download the podcast with iTunes if you want. So for example, here you see I'm using the result here to basically have a podcast of my blog, right? So here then I can use Poly.
New post. Author Cynthia Puranandam. Title announcing.
And this is very useful because it's very event-driven, and it really fits nicely into the serverless paradigm. Poly being serverless, Lambda being serverless, and S3 being serverless. So basically, it's a very nice way to do cool services. Another services which is very interesting is Rekognition. Very successful service. Rekognition offer image analysis. The idea is that you give it an image or reference to an image stored in S3, and it will return a bunch of information. It can extract objects of scene, do facial analysis, face comparison, and things like this. Can also use for image moderation, and it's very simple. It will return you basically a JSON file with the probability for a particular label, or is the confidence ratio of that label for the particular API, what it's returning. Similarly, for facial analysis, if you send a photo, it will be able to give you some information about the age range of a person, whether it's smiling, and a bunch of information. Also, it will give you the location of the face on the image, so then you can do some overlay on that face. For example, with OpenCV, you can do facial search. So given two images, you can in fact compare the different faces as well with a confidence index. So in that case, you see there is only a good match between those two. You can do celebrity recognition. This is something which was launched quite recently, and basically you can, in that case, send an image of a celebrity, and recognition will return you the name. And of course, you can do image moderation, and this will return you basically a result of whether the subjectivity of a photo is high or not, and then you can use that parameter to treat an image as a valuable image or not. And in fact, there's customers use that for social networks, in fact, to moderate image. One customer that is doing really cool stuff with recognition is ArtFinder. Basically, they use recognition to add extra metadata on images, so that customer can then search related or find images or find art that looks and feels like some references. The API is very easy. You can send the AWS recognition detect level API, and then here you have a reference to an object or an image that you host onto S3, and same with detect faces. One very common example, for example, is to use step functions, in that case to orchestrate the extractions of information from an S3. So an image that is stored in S3, extract metadata, then invoke recognition, and then generate thumbnails. This code is in fact available on GitHub as well. And I'll send the link at the end of the presentation, but I want to show you a demo a little bit to show how this works. Here, so for example, you see I have an image of my application running there, and I can select an image, start like this. I'll push this one, and what it does is it uploads the image automatically into S3, then launch different Lambda functions, orchestrated using step functions, and then returning the results. And you see, it's very nice because I just upload an image, then extra metadata that you can see here, and then I also use recognition to add automatic tags to an image. So this is very useful for photographs or media companies that want to automatically index their media assets. In fact, there's also customers that extract images directly from videos and then index videos like this. Let's go back to the presentation. The last very high-level service is Lex, which is a conversational kind of engine. It does speech recognition and natural language understanding. So you can, in fact, it's the engine that powers Alexa, and it allows you to create very interesting conversational bots where you would have a human or a person talk or send text to Lex, and then you can extract information from that text and then start a Lambda function to do very advanced conversational application. Very common use case is, for example, if you want to book in a hotel. And a couple of things that you need to understand when you use Amazon Lex is an intent. Intent is really what you're trying to do. So if the action here is book a hotel, returns is really how you're going to invoke a particular intent. In that case, is I'd like to book a hotel. And then slots, which are in fact simply customer input data that you need to require to fulfill that intent. Okay, so you would do something like this. You would, or Lex works something like this, that you speak, and then it does automatic speech recognition, so extract words, then do natural language understanding, so it's able to detect words and meaning from the sentence, and then you can call lambda function with the particular information extracted from that. And then once you invoke lambda, then you can return and speak to the customer using polyback. So it allows you to do very interesting conversational interfaces with your application. And customers have started to use this a lot. Capital One, which is not on that, but is a well-known user for querying your bank statement, for example, online. But NASA, Twilo, and HubSpot are also very heavy user of Lex. If we look a little bit at the AI platform side, I'm just going to monitor quickly. Okay, so if we look at that, the AI platform is actually comprised of machine learning and kind of the classic machine learning supervised algorithm, from binary classification to regression, and it allows you to do a lot of things like fraud detection, personalization, to churn prediction. And machine learning is very commonly used in those, and customers like fraud.net use machine learning to detect fraud in online merchants, in online, basically, payment systems. And you can also use directly EMR, which is Elastic MapReduce, and then use the libraries from Spark, which are the machine learning libraries to run your machine learning. And there you have a bit more choice. It's more so do-it-yourself type of things. So, but it's nonetheless very useful and very powerful. And companies like Tylo use machine learning to deliver near real-time home valuation. And so the Tylo group runs what we call what they call the Zestimate, which has become the de facto standard to evaluate the home in the US. And they use Kinesis, Apache Spark, and Amazon EMR to run those predictions. If you go a bit lower, you have access to something very interesting, and there is really for the do-it-yourself as well, which we call the AI framework, and in particular the AWS Deep Learning AMI, which comes with a lot of frameworks like Apache MXNet, TensorFlow, Tino, Keras, Caffe, and all those are really ready for you to use and experiment with. All those also come very often with Jupyter notebooks, so there and lots of examples, so you can start playing with those. And it's very classic. For example, MXNet, you have access to a lot of algorithms to do work on images, on video, speech, and those are available for you directly on the repository. So let me show you a couple of customers that do very interesting things. Stanford is doing early detection of diabetic complications, and blindness caused by diabetic is a very big problem in the US for men. And in fact, it's preventable if you catch it early enough. But it's very difficult because a person needs to look at the image and detect very small changes in blood vessels in the back of the eye, and and it requires humans that are very highly trained and skills that are not available everywhere. So it doesn't really scale globally. So what they've done is they've trained a deep learning model and they took pictures of healthy eyes and then they trained that model, and they are able now to predict diabetic complication with an accuracy of about 90%. So it's very, very good. Another company doing very cool stuff with deep learning frameworks is TuSimple, which they use MXNet to do autonomous driving systems. You can see here performing live driving. And in fact, I want to show you a little demo of that because this is very interesting. In fact, for developers, I think it's very important to have an understanding of what it is. So the deep learning AMI, when you start it, if we go into the console, I want to show you how to start it. It's very simple. You go into EC2, and then what you can do is start the marketplace. So if you want to start an instance, and you can go in the marketplace here, and you say you just click deep learning, and here you will have access to the deep learning AMI, and there you just launch it, and what it does, it will launch from basically the AMI on your account. Then what you can do is connect your systems to it. So for example, here, I connected using SSH. Here you can see my comment. I connected using SSH, and then what I can do is I can access my here directly the Jupyter or actually the deep learning AMI here, and hopefully it's gonna work. No, because obviously security groups. So let me just quickly show you there. Here I started an example for running neural arc demo. Basically, it's one of the mini demos and example that you will have when you launch this AMI. And the good thing is that you have access directly to the code. You can understand and learn and see what's happening live, and then change parameters. Here, for example, this was the example, and just use my own image to be able to train the system, and especially use a style and then apply a particular style to another image. And then you can change parameters, and at the end, basically, you can really learn and see how machine learning systems are working. And this is, in my opinion, one of the best ways to get into AI, and especially understand what are the differences between the framework, the algorithm. Okay, my God. But yeah, so I really encourage you to look at it. And the very nice things with it is that once you've done this kind of your own training, you will have models. And the very good way to use the models, if you want to have an API in front of it, is to store it into S3, and then, for example, use a Lambda function with an API gateway to query and load the model in Lambda, and then do prediction. Of course, you can't use all the different models. Some models or training take a bit longer, but there's a lot of models that are sufficient with Lambda. Another way is you could use, of course, ECS. And there's a bunch of programs. So here, if you look at that, there's a blog post that allows you to use Lambda, that explains how to use Lambda and MXNet to run predictions at scale. But there's also other systems that you can use. For example, ECS, and there are blogs that you can use MXNet and ECS. Here, so it's all part of the AWS lab. So I really encourage you to have a look at the AWS lab and see the examples how to run predict functions on ECS. And this is ECS allows you to be a lot more flexible, because you are not running into a timeout of 5 minutes that you have with Lambda, so you have a lot more options. But nonetheless, I think those are very cool use cases that you should at least explore if you are into AI. And then on the low level, the ecosystem. I just want to do a quick shout out to with the EC2 P2 instances. In fact, there's a lot of customers that are using EC2 instances to write their own framework, write their own model. And this is really, if you have machine learning or AI scientists in your company that you can leverage the full power of those EC2 instances, especially the P2 instance that allows you to run GPU. So company like Netflix, I've used bare metal EC2 to run their recommendation engine for a long time. So what they do is they in fact have a recommendation engine for each of their customers. They say that they don't have one recommendation engine; they have millions of those because they're able to compute one for each of their customers. So what we see is a democratization of AI, and in fact you can say that there is AI for everyone, whether you are a really hardcore developer or you are a developer that just wants to have very high-level services and especially enable your application to handle conversation or to speak or to do easy recognition. So I really encourage you to look at the entire set of AI offering. And there's a lot of blogs as well that you can use, especially the artificial intelligence AWS blog that publish a lot of cool articles regularly that you can leverage for your workloads or give you some ideas. All right. On that note, I just want to thank you. I think we're going to take some questions online. I'm a bit late, but hopefully we have time for some questions. If you have questions, you can type them in the chat. So let me look here. So that's the image of recognition has to be in S3. So no, there's two ways of passing an S3, an image to recognition. You can either pass it directly in your request, or you can use a reference. I like to use a reference because then recognition is able to access the data from S3 directly, and you don't have to load the network with very big images. So if your system supports S3, then I encourage you to use references in S3. It's going to make your performance a lot better. When will there be multiple language available for Alexa, example Dutch? I'm not sure, to be honest. So I know we have a lot of customers asking for those. So I would suggest stay tuned and look at the blog. I'm pretty sure in the fullness of time we're going to have a lot of language supported. Is it possible to use Alexa speech cons in Poly TTC? So yeah, in fact, you can. Well, it depends what you want to do. I'm not sure if I understand the question very well, but you can use Alexa and then plug Alexa with, for example, a Lambda function that could call Poly. Now, if you can use, in fact, you can use Alexa as a service to call Lambda function pretty much anywhere. Now, I'm not sure what you want to do with Poly TTS. So if you could give a bit more details on the questions, I would try to answer. Do you support Swedish? So for which language? For Poly? So Poly does support Swedish. So let's have a look. Here we have Amazon Poly, and in fact you have a bunch of language here, Swedish. So let's reload that and put Swedish.
Hejsan, jag heter Astrid och läser upp det som skrivs här.
So yeah, I strongly suggest you look at the console and try by yourself. It's super easy to get started. Is it possible to use recognition for video analysis? So there are customers. So currently, recognition supports only images and no videos. But Customers do extract iframe from the video streams and then send that to Recognition. For example, C-SPAN does that, and a bunch of other customers that are not referenceable that I know of are doing the same. And they do it very successfully. So yeah, it's something that you can do. Is there a tool for text mining? No, there's not an AWS service for that. Which of the AI getting started guide have you found most helpful? Stanford, A16Z, others. Right, very, very good question. I wouldn't say there's only one guide. I love to follow, the AI blogs, Amazon, because there are a lot of guest posts and a lot of posts about how to use it. But Stanford, if you want to get started with AI and understand let's say the mathematics behind, is very good. And I have to say that I like it a lot as well. So, but yeah, I don't have a favorite. I think there's a lot of different documentation and articles, and a lot of them are great. So I think it's just follow a couple of people that are into AI, and usually they post very cool stuff. Is there any sort of time plan for adding more language to Amazon Lex? In the case, it's Swedish, but I'm sure all other languages will be interesting. Yeah, I can tell you there's a lot of customers asking for language support, so that's something that we're working on heavily. So I suggest just to stay tuned and hope for the best. There's a lot of questions there. Is there a particular programming language you would recommend for Lambda function at AWS? So very good question, and this is not really related to AI, but my favorite for Lambda function is Python, simply because I like Python and I think it's very easy to use. You can make it simple and complicated, but I think it fits very nicely into the Lambda ecosystem. There's so much libraries available, so yeah, I really like Python for that. What are the costs of Amazon AI compared to Vision API, for instance? So unfortunately, I don't know the cost of the others. For all the AI services, you can directly access the costs on the page of each services. So it's something that is on the documentation. I wouldn't be able to give you the price per region for each of the services because simply I don't know everything by heart. Swedish also for speech to text. No, currently we do not support that. How to take neural networks with input size of that varies, like 3D models, mesh. So yeah, I'm not sure. I'm happy to take these questions forward and try to answer it later on. We'll send you an email. If you can send us your email, then I will forward you to some expert into AI that can maybe help you on that. All right, and there's no more questions. So if you have any, there's another question coming in. Only certain voice available in Poly now. Any idea of custom voice implemented in future? Well, this is the questions I get a lot. So if you want, Poly will stay high-level services. So high-level services there are services made easy for you to use. So currently you can't just customize a language, and in fact, customizing a language would be it's not straightforward to do it. It takes really large-scale networks to be able to do text-to-speech networks. But if it's something that is interesting for you and you need it now, I suggest you go have a look at the deep learning AMI. And in fact, there are customers using MXNet, TensorFlow to do neural networks that are able to do text-to-speech. But yeah, it's a lot of work, and you need to really know what you're doing. But in the future, if there's enough customers asking for a feature, we always look at what our customers are saying, and then we try to see if we can do that. So yeah, if it's something that is important and a lot of customers ask, in the fullness of time, it will come eventually. But I can't be certain, right? I can't tell you if it's going to come for sure. How to teach neural network with, okay, this is, yeah, cool. I think I got the email. Thanks, Matti. All right. Any other questions? All right. So if there are no more questions, I think we can call it a day. And on that note, thank you very much, and have a great day. Bye-bye.